Hello everyone, my name is Gaurav and my teammates are Rahul and Vamsi. We have made a project on scene text recognition where we have deployed various methods and we have tried to come up with the results so that we can detect text out of the images. In the process, the first method which we have applied is Easy OCR, which works by leveraging deep learning models. And in short, it involves a few steps to execute the task. For example, the first step which it takes is image pre-processing, where it goes on to reduce the noise and enhance the quality by typically converting the image to grayscale. Then we apply text detection. Then it applies text detection, where it uses a neural network to detect regions of image that contain text. Further, it goes on to apply another layer where it goes on for the functioning of character recognition. In this, the network is trained to identify a wide range of fonts, styles, and can handle text in various languages. Finally, it also applies next kind of a network in which the task is to form a word and sentence. This is based on the training which it gets on language models, and the training is incorporated in such a way where it can handle variations in spellings, grammar, and punctuations. Overall, this is an easy method designed to be flexible and adaptable for wide range of languages. In particular, we have used this method for uh, for uh, for image detection and text detection. So this is where we have first installed the dependencies. After installing the dependencies, we have defined various kind of functions like single line, multiple line. Also, we have used various images, and we have given the paths to this model. Further, en, for example, in this code denotes English as a language. We have tried to come up with the results. Further, we have tried also to take this thing into to a next level while trying to detect number plates. In this, first we have converted the image into a grayscale, and then applied the filters. In general, Canny filter was used for this particular task, and then we applied contours and applied masks on it to get the results finally. Now the next method would be explained by Vamsi, and yeah.
Okay, so now let us start with another model, that is EAST. So EAST is also a model which leverages the deep learning models in order to find the text in the image. So here, before going into the code, let us see what is an EAST. So EAST is the deep learning model which uses the general deep learning frameworks to recognize the text in the images. It is a fully connected network which outputs per pixel predictions of the word, and it uses non-maximum suppression per pixel in order to find it whether there is a text in the pixel or not. And it returns finally the losses for the score map and geometry as a loss function. It gives the bounding box across the text in the images. So here the general flow goes this way. It loads the weight using OpenCV deep learning modules, and it samples the images and forwards the images and to get the probability and geometric text. And after that, detecting the regions, the score and the geometry is used in order to threshold whether with the confidence scores. And finally, we use non-maximum suppression algorithm in order to suppress the weak overlapping bounding boxes in order to get the defined text around the box. And after that, we use PyTextRat or any else feature extraction models in order to find the text in the image. So now going into the code which we have done. So here there is a dependency of PyTextRat, so we have installed it before, and these are some prerequisites required libraries that needs to be installed. So as I told earlier, we have used an EAST text detection model, which is a pre-trained model available on the internet. So we have downloaded it, and after that we have defined two functions, which is a model and another one is a text detection. In the model function, what we have defined is we have taken an image path as an input, and we have resized the image, and we have find the width and the height of the images. After resizing it, we have read the model, the EAST model, which was earlier downloaded from the online, and after that we have finded the regions, the blobs, which are ROIs, which are known as region of interest, where the text might be. And after that we have using the EAST model, we have found the scores and geometry of the text, probable text in the images. And after that we have used this prediction models in order to find the text and return the confidence scores and images and the height and width of the image, and bounding boxes. And after getting those outputs from the model function, we have used text detection function, which takes those outputs of the model function and finds the text in the image and puts the bounding box around the text and the image. So this is the example for model which we have taken here, and we have used some custom data set. We have got a custom data set. So this is our college pic. So here we have given input image of admin building. So here we have found the bounding box regions coordinates, and after that, using pytesseract, we have extracted the text in the bounding box and we have plotted it here. So this is the output. So I have taken another image which it is written eye wash. This is the input image, and it has given the probable coordinates of the bounding box. And after getting this bounding box, it has extracted the text in the bounding box and it has printed over here. So here we have used WER as a performance metric. WER is word error rate, which it generally takes in ground truth labels and the predictor labels and finds what is the error between those two words. So we have got here 0.66 as an word error rate, because it was okayish as kind of such, because we haven't taken many images in order to test our model.
So in the last method what we have used is FORTS, that is fast oriented text spotting with a unified network. Generally what we are doing was we are dividing the two tasks, that is detection and recognition, to be a separate task, but in this the author has proposed to do the text detection and recognition text simultaneously. This is the overall architecture which has been taken from the paper itself. Before explaining the overall architecture, first I would like to talk about the data sets and its pre-processing. The data set which I have used over here is ICDAR 2015. It consists of 1000 training images with less focus on text and less legible. That's the reason why the text recognition model and building that model was really tough for us. The second was the data processing task. In data pre-processing task, what we have to do is to separate the text from the non-text part and classify those pixels which belongs to text and classify those pixels which does not belong to text. Now coming to the overall architecture of this FORTS, the first image is fed into the shared convolution. Feature maps that are to be used in the text detection branch are extracted with shared convolution. The architecture of the shared convolution is shown over here. This is the architecture, and the backbone of the shared network is ResNet 50. After that, we will talk about the text detection branch. In the text detection branch, the text detector takes the output of shared convolution as an input and returns the predicted score map and geo map. For this, the losses what we have considered are the classification loss, which involves in classifying text and non-text pixel, as well as the bounding box regression loss, the loss which involves the predicting bounding box vertices and orientation. And the second thing which we are going to consider here is ROI rotate. In ROI rotate applies transformation on oriented feature regions to obtain axis aligned feature maps. These axis aligned feature maps are fed to the text recognition branch. Okay, for now going to the text recognition branch. In the text recognition branch aims to predict the text label using region features extracted by the shared convolution and transformed by ROI rotate. In this text recognition branch, the losses which we have considered are CTC loss. TensorFlow provides function to calculate the CTC loss for variable lengths in the input labels and the predicted labels. And in overall, this FORTS model is a combination of text detection and text recognition losses. So the final inference pipeline works as follows. The 512 cross 5123 reshaped input image is fed into the detector model, which will predict the text pixels and localize them in the image. Using thresholding and NMS, non-maximum suppression, on these maps, the bounding box with maximum IO is obtained. The ROI rotate takes the input from the predicted bounding box and transform it to axis parallel box. The text region inside the bounding box is reshaped to 64 cross 128 cross 3 and fed into the recognition model to predict the text label. So here the results what we are getting. This was our own data set. So as you can see, the detection box is working a bit fine, but the recognition model is failing very poorly due to the less amount of data that we have in our ICDR data set. The results. Yeah, so these are the results for the ICDR datasets. Again, the detection model is working a bit fine, but the recognition model is failing, as I told above, that we don't have as much dataset, and neural networks requires a lot of datasets to get trained very well. So this is the overall three methods which we have deployed in our project. Thank you.